MySQL Security Basics Part 2 of 3. Whereas in the previous nugget we looked at MySQL security more globally from an operating system perspective, now we're looking at just one subsystem of the operating system, namely the file system, which is the component of the operating system on which the MySQL binaries and data files and configuration files reside. This is an important aspect of security, so listen up, pay attention, and prepare to learn a lot. We'll also look at a subcomponent yet of securing the file system. We'll look at protecting the MySQL log files. As we've previously discussed, the log files do contain sensitive data that you do want to protect against falling into unauthorized hands. Let's get rocking. MySQL file system security on the Nix platform. Now, a little bit earlier in the course, I mentioned that we would look at both MySQL running on Nix and in Windows. And so far in the demo, in any demos I've done, we've been on LinNugget, which is a server running, you guessed it, Ubuntu Linux, just as an example. And I mentioned that whenever we run into variances in functionality with MySQL between Windows and Nix, we would introduce them at that point. At this point here in the file system arena, we begin to see some rather significant variances in functionality between MySQL on Nix and Windows. Therefore, the way I'm structuring this particular nugget is first we'll look at Nix, then we'll look at Windows, and we'll compare and contrast functionality between those two OS platforms. Generally speaking, the principles are the same. The difference lies in the implementation and the specific features supported by Nix and Windows. Now, our goal here on Unix Linux is to use a dedicated non-administrative OS account for MySQL management. You'll recall we introduced this in the previous nugget where we talked about operating system security. Now, there's a couple things at play here. You know, in Unix Linux, best practice states we want to log on to our Unix Linux servers not as root, but as a standard unprivileged user. The reason for that being that if some malicious code or a malicious user were to hijack the operating system, they would generally execute under the privileges of the currently logged on user. And if we were logged on to the system as a standard user, then that malicious code would execute in the context of a standard user and would theoretically do less damage on the system. Similarly, if we install MySQL and the MySQL daemon or MySQLD is running under the security context of a standard user account instead of, heaven forbid, root, then if MySQLD falls into the wrong hands and is hijacked by a rogue process or a malicious user, then MySQLD can be steered in a far less destructive direction than if MySQLD were running under root. Simple as that. Now, again, the principle is this account, this dedicated non-administrative OS account, which a lot of DBAs, for simplicity, will name MySQL. And in the upcoming demo, that's exactly what we're going to do. This account will be configured to own all MySQL files and directories. And that makes it simple because that way we don't run into any permissions problems. MySQLD will own the binaries, own the data files, and it would have no problem opening files, running executables, and so on, because MySQL, the user, and MySQL, the associated Unix Linux group, would own those files, and as you know, if you own a resource, you have full control permission over that resource. And that's excellent, that's just ducky, and we've, in a sense, sandboxed that resource such that even if, in a worst-case scenario, somebody were to hijack the MySQL account, they may be able to do catastrophic damage to your MySQLD and associated MySQL processes, but they wouldn't be hijacking the rest of the server because you've contained and constrained ownership just within the database system. Now, how would this affect your client programs, in particular, your MySQL client? There, you'd want to make sure that any client programs are world executable, obviously, otherwise your users would not be able to execute those programs. Whether it's the MySQL client that comes in box with the MySQL server software, or if it's a homebrew client application or a third-party application. That just makes sense. You want to make sure that you set your permissions on your client programs with least privilege. Remember the principle of least privilege that we covered in the previous nugget, such that your user base does have execute permission. I've already mentioned this. The server should never be run as root. And then if you always want MySQLD to run under the auspices or under the operating system credentialing of a particular user, you can set that in your MySQL option file, which, as you know, is my.cnf. In the MySQLD section, there's a directive called user, and we can say user equals, and then you specify the OS account, and you're off and running. Securing the MySQL installation Nix version. Truly, friends, the way to really get a handle on securing your MySQL installation from scratch, and that includes having full control over your file system permissions right out of the gate, is to compile your MySQL from source. Now, if you read the literature at the MySQL website, the MySQL folks will not exactly try to talk you out of compiling from source, but they'll say, well, if you download one of our pre-compiled packages, you can make use of our quote-unquote superior compilers and this, that, and the other. And it's easier if you download a pre-compiled package and so on. And certainly there's some merit to that inasmuch as it's easier, frankly, to install a pre-compiled package or a pre-compiled binary. It can be a lot of trouble and a lot of work, especially if you're fairly new to a Unix Linux environment and if you have limited experience with compiling your own software to do a MySQL installation this way. On the other hand, there's some huge advantages to compiling your own MySQL installation from source. I can give you a few of them right off the top of my head. And really, they all fall under the umbrella phrase, maximum flexibility. You can choose where you install the software instead of just the package directing you to varlib MySQL and so on. You can pick and choose which components you install. I mean, we're talking everything from which storage engines you want to include. That's probably one of the biggest reasons why some database administrators choose to compile from source, because they want to pick and choose which components they want in. And from a security standpoint, that brings up the idea of least service, doesn't it? Because if we leave out entire components that we know we don't need, for instance, storage engines and other features that we know we'll never use, then that leaves entire components out of the picture completely that we don't need to worry about or look at as we wind up upgrading and patching the software and potentially inadvertently introducing security vulnerabilities that could be capitalized upon by malicious code or malicious individuals henceforth in the future, you see. Now, the ability to compile and install software from source has historically been an open source Unix Linux thing. There are ways to do the same thing, to compile MySQL from source in Windows. You can check out mysql.com website. They have ways to do this. It's definitely not easy to do, but it is possible. In the demo, of course, we're going to go about it the traditional way, and we're going to compile a source distribution of MySQL Community Server on a traditional Linux platform. And this code sample, which I grabbed directly from the MySQL documentation site, gives you a very compressed nutshell overview of the general procedure for compiling MySQL. And just to give you the 1,000-foot view, don't mean to be overly simplistic here, I'll just break it up into phases. What's going on here is we're first creating a MySQL user. Now this is going to be the non-privileged standard user that's going to own the MySQL binaries and MySQL data files, all right? So we're creating a MySQL user and MySQL group. And in our demo, we're actually going to log on to the OS as that user to make things a little bit easier yet and to subscribe to least privilege. Next, after you've downloaded the tarball, the tar.gz, the compressed source of the MySQL community server, you'll want to unpack that using whatever unpacker or unzipper utility you have on your Linux Unix operating system. After you've done that, you'll want to cd or change directory into that folder, and then comes the configure, make, and install three-step waltz that a lot of folks, maybe you have, maybe you haven't, have done if you've ever done a compilation from source, which is pretty much de rigueur in Unix Linux. By the way, to come back to my original thesis, yet another advantage of compiling MySQL from source besides the notion of maximum flexibility, where you can choose where to put the software, you can choose which components to leave in, which to leave out. Another advantage is that you have the ability to do a secure by default installation instead of having to kind of, quote unquote, trust the installer the first way through and then have to iteratively come back and repair permissions. That's historically been a problem with Microsoft software. I've often visualized it as an inverted pyramid where you do a installation of some kind of server software that's open by default, and then you have to go back and pare things down. If you're compiling from source and you're making the right choices as you go through that compilation and installation, you can do a secure by default installation where you're as locked down as you need to be initially, and then it's up to you as a DBA who remains in control, and you can gradually relax security on your command as your business needs dictate. Now that's the way it should be. Now the bottom line with this configure, make, and install deal, if you don't know, is that the configure actually refers to a script. Configure is a command that initiates a script file, and what you're doing here is not compiling anything, but you're simply assigning values to variables. And what we're going to do in the demo is I'll just show you a little bit. You can run configure with -- help to get a list of all of the MySQL specific variables. And you'll want to spend time on this step when you run your configure script, because this is where you can completely customize your MySQL source installation. This is where you pick and choose your installation directories. This is where you choose which components you leave in and which ones you jettison. This is an important step. And this, of course, is a step that oftentimes hangs up if you have dependencies that you need and so on. And there might be a lot of iteration and headaches and pots of coffee and so on to get those resolved. But if you can make your configure script, you get what's called a make file at the end of that process. You run the Linux Unix command make, and that will actually build the binary or executable program from the source code that the configure script is working with. Once you've built the executable, you've compiled your source, and then you run make install as root to actually perform the installation. And really from there, it's just your post-installation tasks, and this is where you're doing your secure by default, your customization, your cleanup, and your security. This CP line here is what we're doing is taking one of the built-in MySQL config files. You've got my medium, my large, and so on, your built-in option files, and you're copying it over to its live production location, etc, my CNF, and you'd tweak that up as you would need to in your production environment. Then you'd switch on over to your user local MySQL, which is the default location when you build from source. And then this is really the meat and taters of securing the installation. You would use chown and chgroup to change the ownership of those directories and files and your binaries to the MySQL user. See, that's critical. Now these lines here just assume that you want to change the ownership back to the root user, but that's not what you'd want to do if your goal was to have the owner of all of your MySQL installation files be MySQL, so you can actually ignore those two lines. MySQL file system security, Windows. Now that we've spent a good deal of time looking at the Unix Linux side of things, let's take a look at Microsoft Windows. Now in the previous nugget I mentioned that Microsoft information security model called Defense in Depth. However, I forgot to give you the hyperlink, so let me do that now, because even though it's not covered on the exam objectives, I really have gotten a lot of mileage out of Microsoft's Defense in-depth schema, and if you haven't heard of it, I would recommend you take a look at it and see what you think of it. I think it's pretty worthwhile. Now then, back to the exam objectives. Some specific suggestions from the MySQL team. Number one, you should be doing this anyway on all of your Windows servers. In fact, I don't think it's possible, practically speaking, to go back to the old FAT32 file system. But you should be using the new technology file system, or NTFS, strictly on all of your local drives on your Windows-based MySQL servers. Now, some basic advantages of the NTFS file system are we have file permissions. Now, several years ago, this was a big gee whiz feature in Windows, because several years ago you had a choice between FAT32 and NTFS for your file system. Now, of course, FAT32 has gotten so long in the tooth, with volume sizes getting larger and larger and larger, FAT32 is really not relevant aside for teeny tiny little flash drives. So it's kind of like really a moot point. The fact that we've got the ability to set permissions not just on drives or volumes, not just on folders, but on individual files, that's really not a big deal. We've been able to do that in Unix, Linux, and Mac for a long time, and we can do that in Windows. It's crucial. It's just absolutely necessary. And those permissions on the files obviously would take place locally. In other words, if somebody were to have local keyboard access to the computer, those file permissions would be just as valid then as if the user were logging on remotely from over the network. Another neat thing about NTFS is that it has historically been a self-healing operating system. You may know that a file system is in effect a map. When you perform a high-level format of a volume, we develop, again using somewhat simplistic language, a map of these allocation units called clusters that, generally speaking, with NTFS are approximately 4 kilobytes in size. And that allocation unit means that if you store a 2K file on a file system in Windows, that 2K file will occupy how much space? Yes, 4K. And if you store a 6K file on the file system, it's going to occupy 2 clusters because 4K is the minimum allocation unit on that disk. Well, cluster is the file system's allocation unit, but the 512-byte sector is the actual disk's smallest allocation unit. And NTFS is actually self-healing down to the sector level. In other words, if it finds a bad sector, it'll mark that sector as bad and not store data there anymore. It's pretty cool in that regard. Another neat thing that NTFS will do, among some other cool things, is it will journal or allow auditing to take place. Actually, the term journaling can be used with both the self-healing aspect as well as support of Windows NT auditing. That's beyond our scope, though. Just know that we should use NTFS always. Another advantage of NTFS is a Windows feature called encryption or encrypting file system, EFS. More recent versions of Windows Server, like Windows Server 2008, and on the desktop, Windows Vista, Windows 7, have this full disk encryption system that's related to EFS called BitLocker. Of course, when we use encryption, here we're dealing with just first-party Microsoft-based encryption, but really it goes with any encryption system. There's a trade-off there, isn't there, between security and performance. The trade-off is, obviously, we're putting an overhead on encrypted files. In other words, if we encrypt, say, a data file, heaven forbid, then every time that data file is hit by a user, the operating system needs to unpack or decrypt that file. Decryption and encryption is something for the MySQL development exams. You won't see anything specifically on encryption and decryption functions. MySQL 5.x does support such functions. Here we're talking about file system-based encryption. You probably do not want to put EFS on your MySQL data files. I'm just mentioning it here as a possibility. Definitely, the trade-off, in my opinion, not worth it. All right. Next, we have the notion of service accounts. And as I said before, Unix, Linux, we have the equivalent of the daemon or daemon as some people call it. Now, the big deal here is under whose privilege, under which OS account's privilege is your MySQL D running as? Is it the operating system itself or system? Is it an administrator or is it just a standard user? There's your big question. I would tend to go toward the standard user if you want to use least privilege, least service. And that harkens to my final bullet point, especially with Windows Server 2008 where we have user account control. Consider logging onto the system as a standard user or a server operator and using user account control to elevate your privilege only when necessary. As we work toward the demo, we have one final subject, and that is protecting the MySQL log files. The goal here is very simple. How do we prevent unauthorized access to those log files? The solution in meeting that goal is, again, fairly simple. We modify the permissions and or ownership of those files such that unauthorized users simply can't see the files, or even if they were to see them in the file system, they'd be unable to access those files. Now, if you're not familiar with the log files, you could do a couple things. Just get familiar with them, do some internet research to learn about them, or look at my other CBT Nuggets products because we introduce them fully there. Here is a nutshell review. You've got 4 basic log files in box with MySQL Community Server. However, only one of the logs is active by default, and that's the general error log. Now, all 4 of these logs are located, in the data dir, which is a system variable that points to the location where your databases are stored on the file system. And these logs are in the root of data dir. You might recall that your data dir has a subfolder for every database on your system, and then as I just said, your log files are just in the root of the data dir. Error log is just a basic file that records service starts, service stops. It's going to give you an indication of successful and failed startups and stops of your MySQL daemon, of your storage engines, and related MySQL services. It can be useful if you have a power outage or an unexpected outage to give you a fix on when those events took place, and it's a good baseline actually for troubleshooting. The other 3 logs you have to enable either interactively from a command line using MySQLD, or you can set them to start in the option file. The general query log is exactly what you think it is. You enable it and you'll find that the log begins echoing all commands sent to MySQL server. That can generate a fairly large log in short order, so you'll want to be careful how long you keep the query log active for obvious reasons. The slow query log is going to gather less data simply because it will only capture queries that take, by default, 10 or more seconds to execute. You can customize that value if you want to capture long queries or slower queries. So obviously, slow query log has a more specific application. The binary log is kind of a diagnostic / performance tuning / disaster recovery log that's number 1 stored in a binary format that you can't just look at. The first 3 logs are plain text that you can just pop open in any text editor. The binary log is not. You need a special utility to take a look at those contents. But what's interesting about the binary log is, first of all, it will only record SQL statements sent to your server that change. This is the delta character, that modify data. So in other words, it won't record selects. It'll record updates, inserts, and deletes. Number 2, you can use the binary log to perform data restores, which means that binary can come in really handy in a pinch if you have a server failure and your traditional backup won't give you a fine enough restore. You could possibly fill in the gaps, at least partially, if not fully, with the data contained in your binary log. Finally, it's time for our demo. In our demonstration, we're going to perform a source-based installation on a Linux machine. In so doing, we're going to secure the installation by ensuring that those MySQL files are owned by a standard user named MySQL, after which we're going to switch on over to Windows and we're going to go into DataDir and examine the MySQL log files. Okay, let's get this party started. I'm on a freshly installed Ubuntu machine, and I downloaded the source installation of MySQL 5.1.39. I'll show you what I did. I simply visited mysql.com, went to their downloads area, and I'm downloading their free community server. You can choose which version you want here. I went to the 5.1 GA. GA stands for Generally Available. That's their latest stable version. Scroll down to all their different pre-packaged versions. Go down to the bottom of the list, and finally you get to Source. And even there you've got various and sundry platform-specific sources. I just went to the compressed GNU tar archive, which is tar.gzip, tar.gz. It's just fine, generic equivalent of the zip file if you're a Windows person. 21 megs, very lean and mean. I just downloaded that, unpacked it to my desktop. Let me double-click this and show you what we have. Whole bunch of folders, some script files, just very basic, plain vanilla. If you look in the upper right-hand corner, you see that I'm logged on as MySQL. I would open up the Ubuntu Users tool and show you that I'm just a standard user, but I can actually demonstrate that because Ubuntu says that I'm not allowed to access the system configuration. I guess that's proof to you that I'm a standard user here. Now then, I'll open up a command shell. You see I've already navigated into that folder. Now we can kick things off here by invoking the configure script. Traditionally you do that with */configure. Now if we throw in --help, what this will do is give us some really nice documentation that shows us the values and variables specific to MySQL. The only one we're going to do here in this demo is we're going to use the prefix variable, and this gives us the architecture independent files in prefix. In other words, it's going to give us we're going to give the make file the value of the installation directory. Simple as that. But other than that, let's scroll through here really quick, look at some of the other things you can do here. Disable option checking, some really enable profiling. I mean, there's some developer-specific ones that we would generally speaking never need to worry about. NDB, there's some clustering-specific things here. There's partitioning, whether we're enabling partitioning, and then a bunch of storage engine stuff, whether we want to enable or disable those. Just like I told you before, no big deal. To actually run this, we'll do */configure, and then you just pass in your parameters one after the other. As I said, we're just going to do prefix equals, and we're going to use the traditional user local MySQL. And we'll just let that go. What you want to see is this little blurb at the end. MySQL has a website, blah, blah, blah. Thank you for choosing MySQL. If you get an error out, you want to look at the last few lines of text at what errored, and that's probably the component that is not installed, and that's going to be your dependency. You'll have to install it and rerun configure. Looks like we're good to go though, so we can actually run make and do our compilation. Chances are when you run make, you have to be, well, we'll try doing it without root. Let's just run make. Cool. That process took several minutes, but fortunately you didn't have to sit there and watch paint dry like I did. Cool, so that compilation took place okay. Now it's time to do our make install. Now this is going to require elevation as root, so we're just going to go ahead and su to root, and we're going to do a make install. This is also going to take a little while. Installation is complete. Now it's just time for some cleanup and some file system security. First thing we'll do is exit our root session, come back to our current user, our MySQL user, and we're going to use the cp command to dip into the support files subfolder, and we'll just grab mymedium.cnf. That's the built-in option file that has a medium or modicum number of options pre-built into it. And we're going to copy this into Etsy and rename it my.cnf. Otherwise, MySQL will not have an option file. Well, permission denied. How about we su again? Let's try that again. One more time with feeling, right? Makes sense. Regular user's not going to be able to write into Etsy. Support. There we go. All right, so let's now cd into our installation directory. This is really the meat and potatoes, what we've been building up to. And it's just a couple of simple commands. We're going to change the ownership to make sure we're going to use our recursive command, chown r MySQL dot. So basically what this command is doing is we've shifted our focus into the MySQL installation directory, and we're going to ensure that all of those files are owned by the MySQL user. We're now going to use chgroup to do the same thing to make sure that the MySQL group owns all those resources. Excellent. Final step, and we're not going to go too much further here in the name of time. We have some additional stuff to do with regard to log files, is we can dip into the bin folder, and we need to create the MySQL data dir and initialize the grant tables. So we can run MySQL _install db script, and we can run that with the flag, if I can get the correct character, user equals MySQL. And that just runs the script and creates the data dir and initializes the grant tables and so on. So there's some additional stuff that you want to do. You want to make sure that MySQL runs at startup, and you can configure the MySQL safe script and so on. But you have the general flow now. You know how to compile from source, install only those components you need. You know how to ensure that the MySQL standard user owns those resources. I think you've got the main point. We'll finish this demonstration with a quick run-through of installing MySQL 5.x on a Microsoft Windows server, and then I'll show you where the log files are stored and how we can adjust those permissions under Windows. We're on a Microsoft Windows Server 2008 Enterprise Edition machine. I'm logged on as administrator here. Of course, we can easily fire up, depending upon whether this is a domain controller or a standalone server, the appropriate administrative tool to create a standard account. In this demonstration, in this laboratory example, I'm going to remain as an administrator. I've downloaded the full-fledged, the full MSI package installer for MySQL 5.1.39 for Win32, and we'll just, as I said, step through this installation just to run a quick comparison and contrast between what happens when we run a Windows compiled installation versus what we just did when we compile from source under Unix Linux. First step is just a welcome screen. We'll next pass this. We have a choice to do typical, complete, or custom installation. We're going to choose custom so we get asked the maximum number of questions and have the most flexibility here. In the custom installation, the Windows installer here gives us some flexibility in terms of what gets installed. Of course, we want to install the data files. We can install optionally client programs, the MySQL command line shell or the MySQL client, the MySQL command line utilities, all of your command line tools like MyISOMcheck and so on, MySQL admin, MySQL server instance config. I'm just going to leave all of the default stuff alone. We won't install the developer components. Also, check this out. This is easy to just click next and blow by. The default installation directory in Windows is C program files, MySQL, MySQL Server 5.1. In Windows, I've found it to be a really painful experience to be constantly pathing out to that long path. So at this point, if you're doing a Windows MSI installation, you might want to click Browse and shorten that path up to something like maybe at the root of drive C. You can come in and just create a folder here called, say, maybe MySQL5 instead, just to shorten up your path. That's just an idea, but just note that if you blow by this, you're going to install in the default location, which is a lot longer of a path, isn't it? Now, check this out. Even though I specified my installation directory as a short path, the default data dir is still going to be C program data, note not program files, but C program data, MySQL, MySQL Server 5.1. Now, of course, you know, probably, if you've come this far, you should know that we can always change the data dir to any other file system location we want, but just make a note of that before we click install. Once the binaries are laid down, we have a couple of advertisements to click through. we'll just click Next here through those advertisements, and then we're asked to configure the MySQL server and then optionally register. Now, if you're comfortable just popping open an administrative command prompt and configuring the MySQL manually, you can do that. In this example, I'm going to run the GUI configuration wizard. I've had mixed results in having this work, though, quite honestly, so flying a little bit blind here. I'll choose standard config here because it's a little bit faster. The instance configuration wizard does a couple things for you. It's meant to automate server installation. It can automate installing MySQL as a Windows service. You can give it a name here. The default is MySQL. We can configure it to launch the server automatically. A helpful thing, which again you can do easily on your own, is to include the MySQL bin directory where your command line tools are in the Windows search path, where you can launch them from the command line wherever you are. This is a nice thing where the config wiz allows us to set a MySQL root password in line here. I'll do that now. You can selectively enable remote root access, which I will not do, and optionally enable anonymous accounts, which I will not do. Again, that's nice. This is definitely the secure by default route to disable remote access or remote root access and to disable anonymous accounts, and make sure you have a strong password for your MySQL root. Click Next, and then we click Execute and hope and pray that we can start the service successfully and the security settings come through okay. Looks like it happened fine. So let's click Finish, and what I'm going to do is open a run prompt and open the Service Control Manager by typing services.msc, and in there we're going to come down in Windows to the M's, find the MySQL service. We'll double click this and we're going to check out the Logon tab, and this is where you can customize exactly which user account credential the MySQL daemon is running under. Now you notice that the local operating system is the account that it's currently using. That can be fine. However, if MySQL needs to go outside the local server and go across the network, you're going to run into permission problems. Therefore, you can override this and choose this account and provide a local account or even a domain account in a Windows domain environment. Again, you want to be careful about permissions and use least privilege, just like we talked about before. Very final thing, you see I've popped open my data dir under C, Program Data, MySQL, MySQL Server 5.1 Data. This is the directory under which your databases are found. You see that in a MSI installation, MySQL has in fact given us the test default database. We'll want to log into MySQL and drop that in order to maintain best practice. Now, this file right here, this .err file, is our default error log file. And what we can do is right-click this guy and come down to Properties and mosey on over to the Security tab and check its permission. We want to make sure, best practice, that the operating system has full control, our local administrators has full control, and our users group has read. Now, if you don't want users to have any permissions, you can remove them from the list. So it's just as simple as that in Windows. You can modify your discretionary access control list by just looking at this security property page and going from there. Now you can also get a little jiggy with it by removing the users group and adding the special identity called authenticated users. So we could click Edit, click Add, and in this Select Users or Groups, there's a special group that Windows uses called authenticated users that actually doesn't exist in the directory services or local security database, but is kind of a dynamic or special identity that refers to all of the users who are currently authenticated on that local box or on the network. And we can give those folks permission if and only if you want them to. But of course, you wouldn't want those users to have permission to the error file. Now in this case, we've got some additional work to do because permissions are being inherited from the parent folder. So what we'll actually want to do here is go into Advanced and turn off inherited permissions. That gets beyond our scope. I've definitely taken enough time here and given you the basics of file system security. MySQL Security Basics Part 2 of 3 review. In this nugget, which was, like its predecessor, chock full of information, we examined how to secure the file system in both major platforms supported by MySQL, the NIX and the Windows environment. We looked at protecting the MySQL log files as well, finishing with a flourish, a 2-part demo in which we did a source installation as well as examining log files in a completed MySQL installation. I hope that this has been informative for you, and I'd like to thank you for viewing.